Can you solve this challenging A-level circles question from Mathify? The problem states, two circles have the following equations. Find the exact range of values for k where the circles have at least one intersection point. Many students struggled with this question because they tried to solve the algebra without first visualizing the problem. Let's work through it step by step. To begin, let's sketch the two circles based on the information given. The first circle has a center at -5, 3, and a radius of k. The second circle has a center at -4, 2, and a fixed radius of 4. To solve this problem, we need to determine two key points: the smallest possible value of k, where the circles just touch, and the largest value of k, where the circles still intersect. Let's start by finding the smallest value of k. To do this, imagine the first circle shrinking until it just touches the edge of the second circle. At this point, the radius k of the first circle is equal to the distance between the two circle centers, minus the radius of the second circle. To calculate the distance between the centers, we use Pythagoras' theorem. Applying Pythagoras' theorem, the distance between the centers is the square root of 1 squared plus 1 squared, which simplifies to the square root of 2. Subtracting this distance from the radius of the second circle, which is 4, we find the smallest value of k is 4 minus the square root of 2. Now let's find the largest value of k. This happens when the first circle expands until it just touches the far edge of the second circle. In this case, the radius k is equal to the distance between the centers plus the radius of the second circle. Using the same calculation for the distance, which is the square root of 2, and adding the radius of 4, we find the largest value of k is 4 plus the square root of 2. With these two values, we can now write the range of k. The exact range of k where the circles intersect is between 4 minus the square root of 2 and 4 plus the square root of 2. And there we have it. This problem has stumped many first-year A-level students because it's easy to jump straight into algebra without properly visualizing the geometry. By approaching it visually and logically, the solution becomes much clearer. Thank you to Mathify for this brilliant question. And hopefully, this explanation makes these types of problems much more approachable.